Hello everyone, welcome to my channel Data Mine Insight. This is another video in the series of data structure. In this video, we will discuss how queue works, what are the advantages of queue and what are the disadvantages of queue. Make sure to subscribe to stay updated with latest content. I will be going to explain queue in very simple manner with more real world examples. Let's get started. So first of all, we would need to know that what is the queue data structure. So queue is a fundamental data structure in computer science that follows first in, first out principle. So whatever will come first will go out first. So in a queue, the first element added is the first one to be removed. So whatever you have added at the very first place, that will get out of the queue the very first time. So you can think of it like waiting in a ticket window line. The person who arrives first is the first to proceed. So whoever has arrived in the first place on the ticket window will get the chance to get the ticket in the very first place. Real world use cases for queue. So luggage checking machine. So on airport, there are luggage checking machine which works on the FIFO method, FIFO principle. So whatever luggage comes first will get checked first and user can take it up from that machine. So that always follows the FIFO methodology. Next is CPU scheduling. So this is one of the most common application of queues where a single resource is shared among multiple consumers or asked to perform multiple tasks. So this always works using FIFO method in order to schedule the task. In order to perform the task, it always uses first in, first out. So you could imagine that you have requested a task first before your friend, but your friend got the output first. Would not you call it a corrupt system? Because sequence of the instruction are not going to be followed. So CPU scheduling always uses first in, first out. Next is breadth first search. So I have already prepared one video for breadth first search where we have used queue data structure in order to traverse level by level. Next is implementation techniques. So what are the implementation techniques? Queue can be implemented using array, using linked list, and in this video we are going to discuss about queue using arrays. And there are variations like circular queue, priority queue, each with its own specific use case. So in this video we are going to discuss only simple queue. So in summary, queue provides an organized way to manage and process data in a sequential manner. Operation working of queue. So basically queue is an object, an abstract data structure. What is abstract data structure? So in most of the languages queue is already implemented. So you just need to use the enqueue method and dequeue method. Enqueue means if you wanted to insert something in queue and dequeue means if you wanted to remove element from the queue. So all those methods have been implemented already. You can use directly the queue data structure over there. So whenever you have requirement to implement the first in first out, then you must have to use queue only. We have multiple operations using queue, but most of the times we use enqueue and dequeue. So first, what is enqueue? If you wanted to insert something in the queue, then you have to use enqueue. If you want to remove element from the queue, then you have to use dequeue. So what are these methods? Is empty, is full, and peak. These are the part of basic methods like enqueue and dequeue. Let's suppose if you have a queue, in that queue you wanted to remove something, you wanted to dequeue something, and queue is already empty, then you have to check it. If the queue is empty, then you cannot get anything from that queue, correct? So for that we will check is empty. If the queue is empty, then we need to show some message on the screen like queue is already empty. You need to provide some data input in the queue, then you can get it back. Next is full. So let's suppose we have a queue which can store only 5 elements into it, and we have already stored all 5 elements in the queue, and I just wanted to push one more element. So is it possible? Not possible. So in that case, if a user wanted to insert more element into the queue, then we have to specify a message or print a message that queue is already full. You cannot insert element in the queue. So these are the subsidiary methods of enqueue, whether enqueue will use it or whether dequeue will use it. So in enqueue, we are inserting elements. So we need to use is full. If the queue is already full, then we cannot insert new value into it. And if we are removing something, then we have to check whether the queue is empty. Let's suppose if we are at this position, we cannot remove anything. So we have to show some message. So let's suppose if we are at this position, we have already pushed 5 elements in the queue, so we cannot push more element into it. So in that case we need to choose is full method. What is peak? So if you wanted to get value from queue but you don't want to remove it from the queue, so in that case we can use peek method. This method will just simply return the value. So what is the working structure of queue? So in queue we would have two pointers, one is front and one is rear. As you can see here, we have two pointers, green as denoted as front and red denoted as rear. Both are pointing to -1. This is the blank or empty queue. You can see here, this is the empty queue and this is at position -1. And what rear will do? Front will track the first element of queue and rear will track the last element queue. Add up the element in the queue, then rear will track all those elements. Let's suppose we have inserted 1. So where 1 will get inserted? At 0 position. So our front and rear will be at 0 position. Then you have inserted one more element into it. So where this will get inserted? 2 will get inserted at first position. So we will not increase front variable, we will just increase rear pointer. So front will be at 0, rear will be at 1. So rear will be taking care of our elements which we are enqueuing. So next we have inserted one more element, so we will increase the rear, and then after likewise we will follow the same structure. And we are going to discuss in detail. Let's discuss what is enqueue method and how it will work. First of all, as I told you already, check if the queue is full. If the queue is full, we cannot insert any element into it. So we need to check it first. Then for the first element, set the value of front to 0. What is the initial stage? It is -1. So front and rear will be pointing at -1. When we will insert our first element, we will increase the value of front by 1. So it will be at 0, or you can point it to 0th position, 0th index. And increase the rear index by 1. So we will increase the rear index as well. And add the new element in the position pointed to by rear. So we will discuss this in example. All these things are working. So I'm gonna take the example of voter queue. So here you can see we have two pointers, one is front, one is rear, and we have number of positions 4, 0 to 3. So right now we have empty queue. Our pointer is at -1. You can think of it as -1. Let's suppose if this lady if came up to give the vote. So if you see the changes, if you observe what has changed, so our front and rear pointer has changed. Now lady is at 0th position, so our front and rear we have increased. For the first element, set the value of front to 0. So we have set the value to 0, or we increased by 1. It was -1, now we have increased by 1. So now we have increased the rear index by 1. So we have already increased rear index by 1. So it was previously it was -1, now it is 0. Next, one more person has arrived. According to this, first element set the value front to 0. We have already set the value to 0. But here if you see, increase the rear index by 1. So whenever new person comes in, then we are going to increase the value of rear. So this person has come up here. Now we have increased the value of rear by 1. We have not increased the front. We have just increased the rear. And we have two blank spaces as well. We have two more positions to fill the queue. Now one more lady has come up, and now here if you will see, front is already there because the front element set the value to 0. Increase the rear index by 1 whenever we get new element into the array, or whenever we get new user to vote. Now if you see, we have increased our rear till 3. So this is the last position we can entertain. Where is our front? Front is at 0. Where is our rear? Rear is at 3. Now we cannot insert elements, and we will check if the queue is full. So queue is already full, so we cannot insert more elements. So I hope you got the idea what is enqueue. Next we will discuss about dequeue. Dequeue means removing elements from array, or removing voters from this queue. So check if the queue is empty. If queue is already empty, then we cannot remove anything. But here in this example, we have multiple users. So return the value pointed by front. We have to return these values. Value means one by one user will get chance to vote. So here in this second niche, if you see here, there were 4 people. Now here you have only 3 people. One got chance, to vote. So our front get increased. So what is the value of front variable now? Now it is with 1. Next, one more person has got chance to vote. Front got increased. If you see, front is at 2 and rear is at 3. Now this lady has got a chance to vote. Now front and rear at the last position. What is the last position of index? It is 3. So front is also pointing here, rear is also pointing here. Now, if you see the last line for the last element, this one is the last element, reset the value of front and rear to -1. So once this person will get the chance to vote, we will reset our value of front and rear to -1. So here we have resetted our value. So front and rear are already pointing to -1. So now we'll take an example in programming world. So NQ operation, we have already discussed all these points in the last slide. In the starting, where is our front and rear? It is at -1. So we have inserted one element which is 1 at 0 position. Our front and rear is at 0. We have inserted one more element. We have NQ'd. Now where is our front? Front is at 0. We have already placed it at 0 here. Now we are increasing our rear element which is at 2. Again, we have inserted multiple elements one by one, 2, 3, 4, and rear is at fourth place, means fourth index. Front is at 0. Now let's suppose I wanted to remove one element. So it is following first in, first out. So what has come first? The 1. So we have removed 1 and we have changed the place of front variable. So front is at 1 and we are removing all the elements 1, 2, 3, 4, and both the front and the rear is at position 4, means now they are going to remove the element which is at fourth place of index. Now if we dequeue the last element, then what would happen? This will just reset the position of front and rear. So right now our front and rear are at -1. So likewise, we have just followed the principles of Q. Now, what are the limitations of Q? As you can see here, we are just moving forward our front variable one by one. So these are the blank spaces. Nothing can be stored here. So this is one of the drawback. We cannot shift our front and rear by from here to here. So this is possible as well. So this could be possible using circular linked list. We can only shift our front and rear by -1 only when all elements have been dequeued exactly. So front and rear will get at -1 whenever we have nothing in our queue. It could be great. Our rear, once it is reached at final stage, which is at fourth place, then we can restart it from here as well. Like after 4, if we have another element to get inserted, then we can insert it here. So that's not a part of this video. So we will discuss in the next video. That is called as circular linked list. So let's do some practical hands-on. So I have already opened my arena here. So let's do some practicals. So first of all, we have already included stdio.h. Now, as per our slides, we have discussed enqueue, dequeue, is empty and is full methods. So I would like to define the size of array, which I am just taking as 5. Now what are the methods? Enqueue, and what kind of value we are going to take inside? It is kind of type of int. Next is dequeue, and this will not return any value, and this will, we are not going to insert any value in it as well, so nothing is there. Void display, this method we will use in order to display our elements. This is an extra one. So next int is empty. So same as if our queue is full, then this will return 1, otherwise this will return 0. So that's what I'm just using at int. Now let's implement these methods. And before implementing, we need to initialize some variables. Integer, item, size of array, front, I'm just specifying it as minus 1, rear also minus 1. Now we will implement our first method, int is empty. Basically it's a helper method which we will use in enqueue and dequeue methods. If front equals minus 1. So how we can check whether the queue is empty or not? So in order to check that, we need to check our front variable. So if our front is at minus 1, then our queue is already empty. Now we will return minus 1 here, else return 0. That's all. Now we will implement is full method. So how we will check that? If rear equal size minus 1. If our rear is equals to size minus 1, size is 5, and we have inserted at all the indexes, then this means the stack is full. Then it is returning 1, that is stack is full. Next is we will return 0 if the stack is not full. So what would be the position of rear when our stack is full? 0 1 2 3 4 stack, the rear position will be 4. So what is the size? Size is 5, so minus 1. So we are checking that if rear is equals to size minus 1, then return yeah, it is full, otherwise it is empty. Next we will implement void enqueue method. In here I will be using some value. So before going forward, we need to check that if it is already full, then what to do? Show some message. So printf queue is full. Let me give some /n, else. We have already discussed that front, on the very first element we need to change the value of front by 0. So we need to check if front is minus 1. So if it is full, then we will show the message queue is full. Else what we will do, we will check if this is the very first time we are inserting value in queue, then change the value of front by 1. So I have just incremented the value of front and rear. So we are going to insert the value. What is the value of rear? It was minus 1. Now if we are inserting value at the very first time, then what would be the value of rear? It would be 0. Let's suppose at the first time, what is the value of rear? It was minus 1. Now if the stack is full, this will throw this error, this will print this message, then this will check the front is minus 1. We will increment the front by 1 and then item plus rear. So at 0 position, items 0 position, the value will get stored. Let's suppose we have stored another value. So how this will work? Next this will check is full. If it is not full, then this will check front is minus 1. So we have already incremented front by 1, so it is 0. So this will not check this condition. Then at 0, after 0, it will increment by 1, the second place of index. This will get inserted. Likewise it will work. So void dequeue, and now we will implement the dequeue method if is empty, because once we are going to remove something from the queue, then we need to check that whether the queue is empty or not. So here I'm just giving /n, then we'll say queue is empty. else if q is not empty, then we need to print the variable and remove it from the queue. So how we will do that? Dq, we are going to use front, we are going to increase the front. So right now our position, this is a queue. So we have inserted 1, then 2, then 3, then 4, then 5. Now once what we want to dequeue the value, means we want to remove the value. Then what we will remove? We will remove this one. Here what we have done, we have increased our front. You have inserted very first value, front value is 0. So here what we are going to do, we are going to print this message. It is already DQ. Then item front plus plus. So this will return item front. Then this will increment. So this will return items 0th index value. So what is the item 0th index value? It is 1. So it is going to DQ 1 only. So next front value will be 1. Now we will check if front is greater than rear. So when this will comes up, so let's suppose you have reached at the 5th position. Then you will try to insert one more element, so the front value will be more than rear. Correct? At that time, what we need to do means we are at the end of the list of queue. Don't have a space to store. So in that case, what we will do? We will do front minus 1, rear minus 1. You can use single statement as well. Rear equals 1. I hope you are getting my points here. So now next is display method. In order to display our results, we are going to use void display in I printf slash n. I have used display queue. Here I am using displaying queue so that you don't get confused. For I equals front. So we will start it from the front. Wherever is our front, I is less than equals to rear. I plus plus printf %d, and putting some space here so that we can see our result very clearly. Item of I. So let's revisit this program and how we will go. I'm going to use nq1 or 10, then display. Simple method I'm using. Simply I'm using this. Let's run this program. So here you can see displaying queue 10. So what happens here? So first of all, here from main we have called nq method. So where it is, here is nq, the value comes up, it will check if is full. So what is full? If rear equals size minus 1. So q is not full yet, so this will not return this message. This will comes under else method, and this will check front equal minus 1. So yeah, the very first time the front is minus 1 and rear is minus 1. So this will increase the front by 1. So what would be the front value? It would be 0. So then after this will come here, and then at the rear position means we are just used as prefix. So this will first increment, then store the value. So what is the rear? Basically rear minus 1. So we have increased rear. Now the rear value is 0. So we have stored the value at 0 position. Next we have displayed, so we are displaying the 10. Next let me nq20. Let's run this. So if you see, both elements are getting printed. Now dq. That's all. And let me print. Okay, let's just run this program, then we will print it again. So as you can see here, it is displaying 10 and 20. Now we have dequeued one element basically, which is 10. So what has come first? This one, 10. So this will dequeue or remove the element from the very first position. So what happens when we have called dequeue? After display, we have called dequeue. Let's revisit it. So in dequeue, it will check is empty. So we have already inserted two elements. So this will not get executed. Next, this will come under else. Next, this will print dequeue item front plus plus. So where is our front? So right now our front value is 0 because we have already incremented here. So what is our front value? Front value is 0. So this will print it first, then this will increment the value. This is a postfix. So first what it has done, this has printed the very first value, very first 0 position, then this has incremented front by 1. So right now front value is 1. So next time if I dequeue, if you see here, next is 20. So again I have called the dequeue, we have printed then incremented, the front value was 1. So now again we have dequeued, the stack is not empty yet, and it will print dequeue percentage d will replace this. Then after second element, what is the position of the second element? This was 1. Now incremented, the front value is 2. Now let's dequeue one more element if it is possible. Is it throwing the correct error or not? Yes, queue is empty. So we have inserted two elements, we have displayed it, and we tried to dequeue more elements than queue has. Now I have inserted 30. Why I am doing this? I just wanted to show you the message of stack full. So we have to insert multiple elements. I have inserted 5 elements here. NQ 60. So let's run through this. 0, 1, 2, 3, 4, 5. What is our size? 0 to 4. Correct? So it is throwing error. Queue is full. So what happens here? Once we have enqueued, this will get called. This will call this method. So at the very first point, this has incremented by 1, and this is incremented by 1 as well. So this has 0 position. Then after first position, this is at 0 position, this is at first position, this is at second position, and this will get stored at third position, this will get stored at fourth position. So according to our array size, we can store only up to 5 elements, 0 to 4, 0, 1, 2, 3, 4. So 0, 1, 2, 3 and 4. Once we are going to start with this variable like nq60, then is our front variable. Front is 0 because we are just incrementing front at once when it is -1 when we are enqueuing the data. And what would happen to rear? Rear will be incremented each time. So what is the position of rear? Now when we insert this, we wanted to insert this 60, the rear is at 4, and before inserting we have already checked, we have not incremented our variable, we have already checked that it is full. And what is the rear value? It is already 4, which is equals to size -1. Size is 5, -1 means 4. So we can, at most we can insert 4 elements into our list, 0 to 4 basically. So it is showing the message correctly, queue is full, and we have already seen that queue is empty message. So that's all guys. I hope you enjoy this video.